Hello everyone, welcome to another episode from CADEXL. Today I'm going to talk to you about empirical formula and the molecular formula. Now the name of the molecule can be given in two different ways, many different ways actually. Empirical formula, the molecular formula, structural formula, and in the structural formula we give them something called a displayed formula. Sometimes we use the word chemical formula. There are different words to represent a molecule. But the simplest way of representing the name of a molecule or a compound is, or whatever the substance is, its empirical formula, and the other one is molecular formula. So first we'll look at what are those two things, because those are the two common things that commonly come for both Unit 1 calculation in IAS level and also in IGCSE chemical calculation part. So first we'll see what are empirical formula as well as the molecular formula. First we'll see what is the empirical formula. Empirical formula of a molecule or a compound is its simplest atom ratio of the compound. For example, let's say we have a compound called ethanoic acid, which is CH3COOH. This empirical formula would be simplest one. Okay, we'll come back to that next example. So next one will be the molecular formula. The molecular formula is the exact atom ratio of a compound. Exact atom ratio. So empirical formula is the simplest, exact atom ratio is the molecular formula. Now for example, ethanoic acid, the same example I took earlier. Ethanoic acid, CH3COOH. So what is its molecular formula? Molecular formula is exact atom ratio of a compound. 1, 2, C2, 3, 4, H4, 2 oxygen, O2. So molecular formula is C2H4O2. What is the empirical formula of this one? Empirical formula is simplest one. You can divide everything by 2. CH2O. That's the empirical formula. So we are going to look at how we are going to find out this empirical formula and the molecular formula. For a given substance or a molecule or a compound, you can have either the same empirical formula and the molecular formula. Sometimes it can differ. Sometimes the empirical formula, the molecular formula and the structural formula, everything would be the same. For example, sulfuric acid. Right? Sulfuric acid. In sulfuric acid, we commonly use it as H2SO4. What is the molecular formula? H2SO4. What is the empirical formula? H2SO4, because you can't further divide it. So if you can't divide it further, the empirical formula and the molecular formula will be the same. So we'll see how we are going to find out the empirical formula and the molecular formula. To find the empirical formula, we have a simple steps that we have to follow. Nobody will ask you what are the steps to find the empirical formula. Only thing they could ask is to find the empirical formula. Now the simple steps are this. First you have to write the atoms you have, for example with their percentage. Let's say you have, okay, I'll give you the steps first. First you write the atoms with their percentage or the mass percentage. Next you have to divide the value, the percentage from their empirical formula, their RAM value. Right? Divide the mass percentage from their RAM values. Then third step would be divide the simplest, divide the answers you got from the simplest ratio, and then that would give you the empirical formula. Sometimes if the empirical formula comes like 1.5 or 1.3, you have to multiply them by 2 and 3 respectively, so that they get a whole number. So we'll see how we can get the empirical formula for few compounds, right? These are not that hard. First one I have a carbon, hydrogen and oxygen with percentage is 40% of carbon, 6.7% of hydrogen, and 53.3% of oxygen. So we get a compound, a molecule with the atom ratio, carbon 40%, hydrogen 6.7%, oxygen 53.3%. What is the empirical formula? Right. So first you have to divide these percentages by their RM values. So carbon is 12, so I am going to divide this by 12, this one is 1, this one is 16, oxygen. Then get the value, 6.7 or divided by 1, 6.7. This one will be 3.33 when you divide it. This is also 3.33. Once you get up to this point, you have to divide them by their simplest value. So simplest value of the smallest value is 3.33. 3.33. Then you get the ratio like 1 to 1. Right, that is the empirical formula, which is C1H2O. So this is the empirical formula of that particular compound, CH2O. Right, very easy. Now once you find this empirical formula, some compounds they say ask us to find the molecular formula. Now the molecular formula is always present like this. The molecular formula always comes like this. Molecular formula is equal empirical formula into an insert integer. So we have to find out that integer. So that integer can easily be found by dividing molar mass of the compound from the empirical mass or empirical formula mass. For example, for this particular answer, we got CH2O. I can give the molar mass of this compound is 60. What is the molecular formula? If the molar mass is 60, then 60 should be divided by molar mass is 60. Empirical mass, carbon 12, hydrogen 1 into 2, oxygen 16, which gives you 2. 12 plus 2, 14. So ratio or the integer is 2. Then so this is the empirical formula, right? Therefore, the molecular formula would be, you have to multiply everything by 2, C2H4O2. So this thing also you have to remember when you get the answer. Integer is always molar mass divided by empirical mass. Let's do another example that is not easily come like 1 to 1, right? So we'll do another one. So let's say we get a compound like this. Sodium is there, sulfur is there, oxygen is there. Mass percentage is sodium 29.1, sulfur 40.5, 30.4 percentage. Right? You'll be given this one in details. So what we have to do is first divide the RAM value. Sodium is 23, sulfur is 32, oxygen is 16. Now actually sulfur is 32.1, but for simplicity I am taking it as 32 because this can be used for the IGCSE as well. For IGCSE, sulfur is 32. So what is the value now? Here 29.1 divided by 23, that is 1.265. 40.5 divided by 32 is 1.265, the same thing. 30.4 divided by 16 is 1.9. So now simple one is this, 1.265 divided by 1.265, 1.265, 1, this one 1.265, you get it as 1.5. Now if you get something like that, you can't round off that 1.5 into 2. You have to multiply everything by 2. This becomes 3, this becomes 2, this becomes 2. Therefore empirical formula would be Na2S2O3. This is the empirical formula. Okay, that's how Na2S2O3. So if you have like 1.5, you have to multiply everything by 2. Right. Let's do another one. A somewhat different question. Right. It's the second example. Somewhat different example we'll do. Sometimes rather than giving the mass percentage, you will be given the mass like this. in an oxide of lead, there is 22.5 gram of lead, and once the lead oxide is formed, the lead oxide mass is 24.8. We asked to find the empirical formula. That's a very common term that comes for the papers. We'll do an example on the past paper as well. So lead 22.5, the lead oxide is 24.8. So what is the oxygen then? 24.8 minus 22.5. Because the total mass of the oxygen, lead oxide is 24.8. So we get this one like this. So 22.5 grams. So 24.8 minus 22.5, we get like 2.3. Right? Same thing. Lead, simplest level is 207, the RAM value, oxygen is 16. So this one divided by 16 will give you 0.14375. 22.5 divided by 207, that is equal to 0.1086. Simple value is this one, 0.1086, 0.1086, 0.14375 divided by this answer will give you 1.32 or 1.322. So 1.331. If you get 1.3 or 1.33, you have to multiply everything by 3. So this becomes 4 because 3.99, this is 3. So then PB3O4. That is the empirical formula. So 1.33, you can't just take it like 1, you have to multiply by 3. So this is the common one. If you get like 1.5, 2.5, you have to multiply everything by 2. If you get like 1.33, you have to multiply everything by 3. There are cases they have asked you have to multiply by 5, which is 1.2. But very rarely you get this one. With the time being, when you do question in the papers, you will be able to do that one. Right? So that's the simplest way of doing this one. We'll quickly go to the one last one. That some molecules, they say that they have mode of crystallization. So the questions you will be asked to find will be slightly different. For example, last example we are doing. Let's say you have a compound like this. Percentage of magnesium is 10.9, nitrogen is 12.7, oxygen is 72.7, and hydrogen is just 3.7 percentage. So we'll start dividing by the RAM value. 24.3, I just take 24 here, nitrogen 14, 16 and 1. You can take 24.3, that's fine. Then we'll see what are the values we are getting here. 10.9 divided by 24, which is 0.4541. 12.7 divided by 14, that is 0.9071. 72.7 divided by 16, 4.543. 3.7 is 3.7. So simplest value would be this one, 0.4541, 0.4541. Looks like this is 10, this is 1, 0.907. 9071 divided by 0.045. This is 1.99, so this is 2, and 3.7 divided by 0.4541, that is equal to 8. So MgN2O10H8 is a big molecule or a compound. Now if you are saying that this is water of crystallization, you should know that this should have water, H2O. So how can we put this compound to the specific exact value? So if you have H2O, water of crystallization means you should have H2O. You have 8 hydrogen, which means you should have 4 H2O molecules. So it should be 4 H2O. Then what would be remaining? You should have 1 magnesium, 2 nitrogen, and 4 oxygen is there. So remaining is 6 oxygen. N2O6, if it is a compound, now as a practice, I know that this should be a nitrate. So NO3 into twice 4H2O. So this compound would be MgNO3 twice H2O, magnesium nitrate with water crystallization. Right. So this is how we do calculation based on empirical formula and the molecular formula. It's not that hard. That's the common way that we use for the IGCSE, AS, A2 and all of them we use the same pattern. Right. So this is a quick video how we can do the empirical formula and the molecular formula. Actually I did a bit quickly, so I think you can practice this one and get the idea. So the next part of the first unit would be we are talking about the idea or the concept of concentration. So I'll upload that one as well. Okay, this is how we do the idea of empirical formula and the molecular formula, and that's it. Thanks for watching.